By the end of this lesson, we will be able to create a system of equations involving two variables. Systems always involve two or more equations. So we're basically going to be given enough information to create two or more equations, each of which may involve two variables. We will then decide whether we should solve each system using the substitution method or the elimination method, both of which we've been practicing in class. At the end, we will always interpret our solution to make sure it makes sense based on the context of the problem. Create a system of linear equations and solve. While I read problem 1, I'm going to use the cubes practice that we use in class. Lulu tells her brother Jack that she is holding 20 coins, all of which are dimes and quarters. So she's holding a total of 20 coins. And they have a value of, so a value of indicates another total of $4.10. She says that she will give him the coins if he can tell her how many of each she is holding. We need to solve this problem for Jack. Before we can set up a system of equations, we need to identify what our variables are. Jack's dilemma is that he doesn't know how many of each she is holding. So we need to use variables to represent the number of dimes and quarters she has. I'm going to let D equal the number of dimes and Q equal the number of quarters. Now we need to go back and find the information that will give us the equations. So to set up my system, the first thing I noticed was the 20 coins in all. So that means if I have so many dimes plus an unknown number of quarters, their total still must be 20 coins overall. And they should add up to a value of $4.10. So now if each dime is worth 10 cents, we need to multiply 10 cents with the number of dimes, plus each quarter is worth 25 cents. So I'm going to take 25 cents multiplied with the number of quarters, and they should add up to give us a total value of $4.10. Before we solve the problem, we need to choose which method might be better. So let's put this problem on hold for a second, and let's look at the notes at the bottom of our page. So far, we have completed a few of these important steps. We have chosen two variables by setting up let statements. We have written our two equations using those two variables. We're up to the step where we need to solve algebraically using either substitution or elimination. Substitution should be used when it's easy to get one variable alone. Alone meaning it's easy to get one of them isolated or all by itself on one side of the equal sign or the wall in our equations. The elimination method should be used when it's easy to line up and get opposites, meaning additive inverse coefficients. It's much easier to just remember opposites because opposites will add to give us 0. But this is the same as getting our additive inverses as our coefficients. So now let's look at a few other examples before we go back to Lulu and Jack. I want to choose which method I would use here. So first, I notice the x does not line up with the x term, the equal sign does not line up with the equal sign, and the y term does not line up with the y term. So it does not appear that elimination would be best. Let's check for substitution. Can I get one variable alone? Well, it turns out x is already alone, and it's equivalent to this expression here. So in my other equation where I see x, I could replace that x, or my box, with this rectangle, y plus 5. So this would be the substitution method. Let's take a look at the next example. Here, I notice that the x terms are lined up, the y terms are lined up, equal signs are lined up, and the constants are lined up. So here, I do not have additive coefficients yet. However, this 3 and this 2 have a common multiple of 6. So if I multiply this equation by 2 And this equation by -3 will end up with 6x and -6x are opposites, so that when we add the equations together, they would eliminate. I believe this method would be best rather than trying to solve for y by subtracting 3x, dividing by 7, and ending up with fractions used in my substitution. So this one, I would choose the elimination method. Let's take a look at our third example. Here, we end up with x terms lined up. It appears the y terms are lined up, but they really are not. My equal signs are not lined up. So now I would have to make a choice. Would I rather, let's see, if I rewrite this top equation down here, 4x equals y plus 10. I have two options. I could try to line this up by subtracting y over, but then I would still need to get opposite coefficients. So why not subtract 10 over and then see that 4x minus 10 equals y, and all in one step, I end up with y alone. The elimination method would require me to move this y over and then still take another step to get opposite coefficients. So for this one, I would choose substitution. However, just remember, you can always use either method, although one might be easier than another. So now let's go back to Lulu and Jack. Okay, so for Lulu and Jack, this isn't a very easy decision to make. Right now I have my D variable lined up, my Q variable lined up, equal signs, and the numbers. However, I do not have opposite coefficients yet. In order to get opposite coefficients, I would have to multiply this top equation by either negative 0.10 or negative 0.25, requiring me to multiply with decimals. Not so bad. Or I'm actually going to use the substitution method in this problem. If I rewrite this equation here and I choose to just subtract Q over, I realize that the number of dimes is really the total number of coins, 20, take away however many quarters I have. So now I have D all alone, and I know it's equivalent to this binomial expression. So if I go back to my other equation here, my D would be the square, and it can be replaced with my 20 minus Q expression. So if I'm supposed to multiply by 10 cents for the number of dimes, my expression, which was replaced, and then 25 cents with the number of quarters, it's now equal to the value of $4.10. From here, we have only one variable, and we should be able to solve. We need to use our order of operations and solve this multi-step equation. So this is a time where I think you should pause it here, try it on your own, and then press play to check. Okay, here I distributed, I ended up combining my like terms, subtracted $2 over, divided by the 15 cents, and I end up with Q equals 14, meaning that there must be 14 quarters. For Jack, we need to know how many of each coin she's holding. So if I go back up here, I see that the number of dimes is equal to 20. Take away the number of quarters, so subtract 14, which means that there are 6 dimes. At the end, we should always write a sentence and just do a mental check to make sure it works. So she is holding 14 quarters and 6 dimes. And 6 dimes. If we want to make a quick check to see if this works, 6 dimes, we know is 60 cents. Now, 14 quarters, well, 4, 8, 12. That would be $3 for 12 quarters, so $3 for 12, plus another 50 cents for 2 more. And if we add this up, we end up with $4.10. So she is certainly holding 14 quarters and 6 dimes. Okay, problem 2. Bill and Steve decide to spend the afternoon at an amusement park enjoying their favorite activities, the water slide and the gigantic Ferris wheel. Their tickets are stamped each time they slide or ride. At the end of the afternoon, they have the following tickets. So let's take a look at Bill's ticket. He rides the water slide 3 times and the Ferris wheel 3 times, which costs him a total of $17.70. Steve went on the water slide 4 times and the Ferris wheel 5 times, and his total, of course, was more. He went on more rides. So if we want to figure out how much does it cost to ride the Ferris wheel and how much does it cost to ride the water slide 1 time, we need to set up our variables. So let's let W equal the cost of each water slide ride and F equal the cost of each Ferris wheel ride. Now that we've established our variables, we want to create a system. So for our system, Bill's ticket shows that 3 water slide rides plus 3 Ferris wheel rides total to $17.70. According to Steve's ticket, 4 water slide rides plus 5 rides on the Ferris wheel total to $25.75. Now, if we go back to what we looked at before, we have to make sure we choose the correct method. It is not very easy to get one of these variables alone, so this time I would use the elimination method. Now remember, we always get to choose which variable it is we want to eliminate. So there's technically many ways to answer this moving forward. I am going to choose to eliminate the F variable. In order to do so, I need to make both F terms have the same coefficient but opposites. So if I multiply the top equation by -5 and the bottom equation by +3, I'll end up with -15F over +15F. Because we've been solving using the elimination method in class, I think this would be a great time to pause the video, try it on your own, and then check to see if you end up with the correct solution. I have shown both new equations after multiplying. Please make sure you don't forget to multiply the constant as well. This step shown in purple, we've added both equations together to eliminate the F variable, and then we divided to find Y. It is okay that we end up with a decimal answer because this actually represents the cost of 1 Ferris wheel ride. So now we know the cost to ride the Ferris wheel is $3.75 per ride. And we have to go back to one of our originals and substitute to find the cost of the water slide. We can use that top equation, 3W plus 3F equals 1770. Okay, so if we substitute 375 into W and then multiply, we end up with $11.25. Next step, subtract that over. We end up with 3F equals 645. So 3 rides of the Ferris wheel, 645 divided by 3. And we see that now it will cost $2.15 per ride on the Ferris wheel. Margie is responsible for buying a week's supply of food and medication for the dogs and cats at a local shelter. The supplies for each dog costs twice as much as the supplies for a cat. So the supplies for each dog costs twice as much. So twice means 2 times something. The supplies for a cat. I don't know how much that is yet. She needs to feed 164 cats and 24 dogs. So 164 cats, 24 dogs. So cats, dogs. Her budget is $4,240. How much can she spend on each dog for food and medication? So let's start setting up our system. First, we need to know our variables. I don't know how much she can spend on each dog. This is our question. How much can she spend on each dog? But I also don't know how much she spends on a cat. I'd like to let C represent the amount of money spent on cat supplies and D represent the amount of money spent on dog supplies. So now if we start to set up our system, it's going to cost her C dollars for each cat, but there's 164 cats times the cost of each one, plus 24 dogs times the cost of each one, and her budget was for $4,240. But now the other equation is a little bit harder to find. It tells us that the supplies for each dog costs twice as much as the cat. So the cost for a dog equals twice as much as the cost of a cat. Now for this problem, it looks different than others, but it should be apparent which method is easier. I already have a variable alone, so I can use the substitution method. Let's rewrite this equation over here. 164C plus 24D equals 4,240. I have the D here, but D is no longer D. I can substitute it with this expression here, 2C. So when I rewrite my equation, I have 164C plus 24, not the cost of a dog, because it's really equivalent to 2 times the cost of a cat, which equals $4,240. Now that we have an equation in terms of one variable, I'd like you to pause the video, check it on your own. After solving the equation, I get C equals 20. But if I go back to the question, it asks, how much can Margie spend on each dog for food? So if this is $20 per cat, I need to go back up here, and she always spent twice as much on a dog, so 2 times 20, that means $40. So Margie spends $40 on dog supplies. Let's make sure quickly that this makes sense. If I try out my original equation, 164 times $20 plus 24 times $40, we want to know, will it give us the $4,240 that we are looking for? 164 times 20 is $3,280 spent on cats, and then $40 times 24 dogs is $960. When we add these together, we do get $4,240, which was her budget. We are now able to create a system using two variables, and we also know how to choose between each method. We will practice this some more in class tomorrow. Thank you.